I am Antonio Calanducci. I'm a founder of Etna Training. Etna Training is the first Italian accelerator authorized training partner. We run classes on Titanium all over Italy, from Milan to Rome, Turin, Florence, and Catania. I'm also an Apple certified trainer, and I'm a researcher at the National Institute for Nuclear Physics in Catania. So, what we are going to talk today about mobile apps, real-time apps made with Titanium, of course, Node.ACS and WebSockets. Who of you ever used Node.JS? Oh, great, so half of you. And what about WebSocket? Who knows who have used WebSocket? Okay. Socket.io? Okay. So, because I'm going to try to run a demo, if the Murphy law will not happen, if Murphy will stay far from here, I will invite the guy here that has an Android device to download this APK files at bit.ly/ticonf. So if any one of you has an Android device, you will download there an APK files. I'm sorry for iOS guys, but I cannot get all the all of you to make a IPA that works. And at the end of the presentation, we will try to do the demo with your help. So, the problem is to implement real-time application over HTTP. So we are not covering classical implementation through native socket. The problem is that HTTP is a protocol that is half duplex, so that we can have only the communication only one way. And every time that we need to talk through HTTP, we need to establish a TCP connection. So we have the latency of the establishing, the overhead, because we have to send a request to get a response. Even just the headers of the request and the response takes about 800 bytes or 1.5 kilobytes. So one first solution to try to achieve real-time communication over HTTP or near time is AJAX polling. So the client makes a request each seconds and wait if there is some event that has been emitted by the server. The second approach that has been used along the years is called COMET. COMET is actually a term that is used to encompass different technologies. Also it's called the reverse AJAX or AJAX push, HTTP streaming, and things like that. The mechanism works in a different way because we have the connection is started from the client and the connection is held on the server side. So until the event happens on the server side and the server can answer. We have other approach. We have Java applets, Silverlight duplex, of course if we are using the web, and also Flash WebSocket. But all of those require proprietary runtime installed on the browser, and they are not so proxy friendly because they run on different ports than 80 that generally is open on main server. So let's find a solution. Here, let me introduce WebSockets for the ones that never heard about that. It provides a bidirectional and full duplex communication channel between client and server, and works over a single TCP connection, and share the port with the HTTP server, 80 port or 443 for secure WebSockets. And this brings to the fact that it's proxy and routers friendly, and most importantly supports cross-origin. One of the problems that we have, for example, with the mobile web application with Titanium is that we cannot easily implement XHR calls because of that. And the API of WebSocket has been standardized by W3C consortium and now is part of HTML5. But most importantly, it's very lightweight. In comparison to the 1.5 kilobytes needed for a request response, here we have only 2 bytes for each message. This is the header, because it's a real protocol. And only one connection is established. So the TCP connection is established only once, and then all the communication will run through and back and forth to the server just over that connection. So the latency will go down a lot. So here in this slide, we see that the API of WebSockets is super easy. So we instantiate an object of WebSocket, and we have 4 events to listen: on open, on message, on close, and on error. So here the client, this is the API that is used, for example, in a web page, listen on message, and when the message is arrived, we just print it out. Or if the client wants to send a message to a server, it uses the send method of the socket WebSocket API. So, but what is the current support for WebSocket in browser? As you can see here in the bottom of the slide, we are in a very good situation because almost all current browsers support WebSockets. And we have some partial support for Opera Mini or for Android browser, but most of them would support. But we have a solution also for older version. This is called Socket.io. So Socket.io uses fallbacks. So in case the WebSocket API is not available on the browser that the user is using, it will use Adobe Flash Socket, Ajax long polling or multi-part streaming, Forever iframe, and so on. So it's a simple library that can be used both on the client side, so in HTML5 and the other browser, both on the server side, especially Node, and you can easily implement the WebSockets API with a current interface. So what is the best server to implement WebSockets on the server side? Probably all of you have heard about Node.JS. I'm not going to explain what Node.JS here, because tomorrow there will be a nice primer on Node.js by Dev Macintosh. But just to summarize what Node.js provides is asynchronous I/O, non-blocking, event-driven, and as lightweight as efficient. So here we can see 2 examples of how to use Socket.io both on the client side and on the server side. So the first snippet is used as a Socket.io module. So here you require the Socket.io module, and then on the connection event, that is the handled when one client connects, the server emits the news message. So here we don't use send, but we have emit, and on the same time it listens on another message, another event called on my other event. On the client side, we just use the script tag to include the Socket.io JS library. We connect to the server. Notice that we connect to the 80 port of HTTP, and we listen on the news message. So the server will send this hello message, and on the way back, the client will emit my other event that will be get from the server. So it's really super easy. Once you have learned these 3 callbacks, you know Socket.io. So, but what about WebSocket and Socket.io on Titanium? There are 2 contributed free modules that you can find both the source code on GitHub or in the marketplace. They are both free, and they support both pure WebSockets events, so the one that we have seen in the previous slides of the W3C consortium, or support Socket.io, that is an abstraction layer over WebSocket, or another library that now is deprecated is Node.JS. But let me introduce now Node.ACS. What is Node.ACS? It's the accelerator Node.js hosting solution. This means that you can take your existing Node.JS application or services and push in an easy way to the cloud, to the accelerator cloud. Moreover, you can use to build custom services to ACS. ACS is the accelerator cloud services that offer 25 web services ready to use, the backend as a service of accelerator. And tomorrow Javier will introduce, we'll see how ACS has been used, I guess, in his nice app, My Things, I guess. And the nice thing is that Node.ACS is supported directly from Titanium Studio or from the command line interface. So here's the architecture. So we can call services both to the ACS standard web service, or you can build your own Node.ACS services that can talk on behalf of the user to ACS or even to external services. Maybe you're using Mongo. Mongo is very popular in those days, so maybe you want to store your model with Mongoose and Mongo HQ services, so you can use that. So here the workflow. I'm going to show in the command line. So you create an app. You can test the app locally because the command line interface of Titanium offers a Node.js server that you can run locally. When the application works, you can push on the ICS cloud. Just let me create the classical hello world. So let me open up the console, and here I just type ICS new. Let's choose a name with a lot of fantasy. Hello world Valencia. So I'm created this tab of application. I use one of the editors that's is commonly used here. Let me show the structure. So the first thing that we need to know is this config.json. Config.json allows you to map routes, filters, and WebSockets. So suppose we want to create a URL that answers to, let's say, hello. And the controller for this method will be found inside the file application. And the method, the callback, is called hello. So here, if you notice, we have several folders. So we have controllers, we have filters, we have public, we have views, and we have WebSockets. So just have a look to applications. So here we are mapping the /hello method in the application, and we have the new function callback that is called hello. And maybe we can return some JSON that say hello Valencia. And then we save this file. We need to not forget to save this one too. And then we are in the right folder, ACS publish. We should test it locally, but we don't have so much time, so let's push on the internet. And here the magic happens. Okay, we got this URL, maybe. Okay, I use the impaired cursor, and let's open up a browser. And all right, math is okay. ACS locate. Okay, so ICS run. Okay, we forgot yes, the comma here. Let's try. Okay, it's work here. ICS publish. Okay, menu force. Okay, let's cross fingers. /hello. Yeah, we got the output. So 2 minutes and we implemented the REST API. So let's switch back to the presentation. So as we see, this is Node.ACS, and actually they introduced an MVC framework over Node.ACS recently. It's based on Express 3.0, and it provides MVC framework similar to Sinatra or Ruby on Rails. So as you have seen, you can define routes, filters, WebSockets, event handlers that map to controllers. So filters are called every time it match a URL, and it takes care for you of all the details of the configuration environment, and you can focus only on the app features. So let's have a look to the config.json you have seen already. So first paths used to map URL to callback, and here we have two URL slash and login, and filters, as said, are called every time there is a matching. So every time the slash path is called, there is a method validate session that is called, that is written inside the session filter. And the last part deals with WebSocket that we're going to see in a minute. So here we have two events, message and scores. Those two events has the controller written inside chat.js and game.js. So here, the WebSockets folder, we have chat.js, and the callback is do message. So every time a client sends a message event, the Node.JS server will broadcast to all other client message. So this is an implementation of a simple chat. So it's demo time. So let's see how we can implement our real-time survey system using Titanium, of course, and we built 2 different clients, iOS, Android, and mobile web, and we built the server with Node.ACS. So let's head to www.etnatraining/ticonf demo. Okay, nothing happens. You know why? Because I didn't publish still yes, publish. Otherwise, you start playing. How many of you have downloaded the Android apps? Okay, a couple. Great. Yes, I'm almost done. All right. Okay. So now, if you launch the application, if you have done it already, you should kill it. Here, so we have, I know it's a nerd question, but this was the first one that came to my mind. Let me run iPhone Simulator 2, and let me also use my iPhone. Okay, so people are starting to vote, so thanks. So it seems that Murphy is not here, so let's see if my iPhone will come up too. Okay, so I think JavaScript won. So here it's super simple. We implemented this real-time system, and I guess that JavaScript is your preferred language. Okay, so let's see what's going on. Also, we can remotely log and see we have at the moment 10 clients connected, so nice. ACS Cloud is robust, it's not. All right, so just 2 minutes to show how this has been developed, and I am done. As we said, we have the main entry point, that is the config, and we have a single event that is votes. This votes event will be handled under poll.js. Here's the controller, and what happens is just just increase or decrease the question model that we've implemented statically here in a simple array. So we have 2 questions here. And what about the client side? The client side here. So let's focus on the important stuff. Here we set the host name. This is the host name that is returned by the CLI of Accelerator, but you can use CNAME to register your own domain. And the essential point is here we require Sockets.io. We have 2 different versions because the mobile web version needs a different version of Socket.io. And every time that we get our results here, you see, what we do is change the value of the progress bar and of the label on the here to update in real time. And every time we click one of the buttons here, we use the vote function that emits the votes event that will be handled back by the server. Okay, I think I'm done. Murphy was not here today, so I'm happy for that. So here you can find all the reference. The source code of both the client and the server can be found on our company GitHub account, and all the reference for all the technologies that we talk about this today in this presentation are there. So thanks a lot for listening, and I'm available for any question.